Nike. Just do it. Okay. We're looking at example 3 from 5-2 notes, and we're going to write this radical in simplest form. So what we were doing yesterday was we had this option where if it's the 5th root of 7 over the 5th root of 8, I'm just going to write this above it because it's not what I'm going to do. We could try the 5th root of 7/8. But the problem is that doesn't reduce. This doesn't make it any easier for me to do. So trying it this way gets me nowhere. So I'm going to go back to this one here. The 5th root of 8. You may say, this is in simplest form. But I'm going to remind you of something which hopefully you learned in Algebra 1, is you're not allowed to leave a radical in a denominator of a fraction for it to be considered in simplest form. No radical in a denominator. If you have a radical in the denominator, it is not in simplest form. And since the directions say write it in simplest form, we have to manipulate this using secret methods. Stealthy. What are those things called? Math here. Okay. This is what I'm going to do. I'm going to see if 7 or 8, and actually I don't really care about 7 because you can have a radical in the top. You just can't have a radical in the denominator. So I'm going to see if 8 reduces down to like a power. You know what I'm talking about? Factors down to a power. What is 8? It is 2 to the what? 2 to the third. All right. What I want to do, my little stealthy thing that I'm going to do is I'm going to change the appearance of this fraction. I'm not going to change the value of this fraction. So anything that I do right now is not going to change the value. So the only things that I can do to not change the value is either add 0, which is not going to help, multiply by 1. This is my only things I can do in math to not change the value. To not change value, you either add 0 or multiply by 1. Those are the only things in math that don't change value. And that's the only thing I can do, except if I add 0, nothing changes. If I multiply by 1, nothing changes unless I'm smart about it. I'm going to multiply by 1, but it's wearing a disguise. It's not going to look like 1, but it's going to have a value of 1. Okay, so I'm going to multiply by a fraction that has the same thing on the top and on the bottom. My fraction has to be able to multiply and change the appearance of this one on the bottom. And in order to actually multiply these together, it has to be a 5th root of some sort. So I know if I have a 5th root that I'm multiplying by, then on the top I'm going to be also multiplying by 5th root. And then when I'm done multiplying, this is my next thing I'm going to think about. When I'm done multiplying, I will still have a 5th root for a moment, but it's got to be something that has a power of 5, so that when I have a power of 5 and a 5th root, these things undo each other and I just get a number that does not have a radical. So when you're looking at my original, which is 2 to the third, what do you think needs to be the 5th when I'm done? Right now this is 2 to the third. I need it to be something to the 5th. Any guesses? 2. Needs to be 2 to the 5th when I'm done. So what can I multiply 2 to the third by that changes it into 2 to the 5th? 2 to the third multiplied by 2 more 2's, right? Which is 2 to the 2nd. completes that 5. But if I do it on the bottom, have to do it on top. So it has to be the same thing. This has to be a value of 1. So we're just changing the appearance. We're not changing the actual value of it. So when I multiply 5th root of 7 and 5th root of 2 squared, which is 4, what do I get? I get the 5th root of, we're multiplying. Here, I'll just write this. 7 times 4. 11? 77? You're like stuck on that 11. Yeah, 28. Okay, so now I have one more step. I cannot leave a radical in the denominator. So since I have the 5th root of 2 to the 5th root and the 2 to the 5th undo each other. I mean, if I wrote it as a fraction, I would write it as 2 to the power over root. And what would I have for my answer? Just 2. So my answer down below, the denominator will be 2. The numerator will be root of 28. So this and the original question are equivalent. This one is just considered in simplest form. Even though you might look at that and be like, they both look hard. This is just like if you go into math or anything that you have to take math with, college professors and they want something in simplest form, this is what they want. Yes? We want to make it a complete set. Right underneath this, number 8. All right. I hate when they don't give you like different examples, but I'll give you plenty. All right. This is similar. We're starting with, well, it's similar. It's not exactly the same. This one starts as a huge, big radical, 5th root of 3/4. Remember when we were just looking at this example I did, I said, ooh, I could combine it and make 7/8, but that didn't do anything for me. So I'm actually not going to leave it as 3/4. I'm going to separate the 4 special 5th power. So my first step is, not on there. My first step is the 5th root of that root of 3 over the root of, and tell me, is there anything that kind of could be factored down to a power? The 4 could become 2 to the 2nd power. Okay, I'm going to do that. Sounds good. So I'm going to have the 3 over the 5th root of 2 squared. So this there, we're going to what's called rationalize the denominator. That's what we're doing. It's called rationalize. The denominator. Rationalize the denominator. We're going to multiply by a value of 1. It has to be a 5th root so I can continue multiplying. It has to be a 5th root. Think ahead and be like, what should my answer be? In this first radical, I've got 2 2's. Second radical going in there. So when I multiply across the top, I will have the 5th root of 3 times, what is 2 to the 3rd? 8. Which will be 24 in my next step. Yep. So then I will have the 5th root of 20 on top. And then if we have the 5th root and we have 2 to the 5th, those cancel out. They're opposite operations. They're inverse operations. And we get 2. Okay. That's called rationalizing. Should have done that before with square roots. You about square root. Said, oh, the square root of 3 times square root of 3. Right? Oh, I know. No? Maybe. You don't remember. Some of you. Okay. Here's a vocabulary word up here, which I think I've used in here before, but now I can't remember because I teach two other classes. But a conjugate, I'm pretty sure I've used this before. It would be if you have a binomial where the first term and the last term are exactly the same, you just have a plus and a minus in between. So these are conjugates. And if you have, if we x minus 3, we're multiplying those out. This is when the middle term cancels out. Just to remind you about everything here, because we are going to come back to factoring soon. So when you multiply conjugates together, you get difference of squares. Trying to squeeze this in. Difference of did a lot before break, and we'll continue. Forgot about factoring. Good old factoring. Okay, so that up. We're going to write 1 over 5 plus radical 3. I'm going to just rewrite this over here. So we have a radical in the denominator, but it's not a monomial. We have addition or subtraction. We have more work to do. I'm going to show you what a lot of people do wrong. Do you mind if I show you? Don't write it down yourself.
Yeah.
Okay. They'll be like, oh, I have to multiply by square root of 3 over square root of 3. Okay. So if I multiply by square root of 3, I actually have to I will get 5 square root of 3 plus, and then I get the square root of squared, which is 3. Okay. But when I multiplied my denominator by square root of 3, I canceled out the square root from the square root of 3, but I just moved it to the other term now. Just a radical, it's never going to cancel out both of the radicals because you'll keep so on. So this, when you've got friends with your radicals down there, we've got more work. So this is where my conjugates come in. If you have in the denominator a binomial with a radical, you will multiply by a value of 1, so it doesn't change how much this fraction is worth. You're going to multiply by a value of 1. But what that value will be on top and bottom will be the conjugate of the denominator.
We're having internet issues. They people know, so it's probably not going to have a problem. The internet might as well. Also, I'll interrupt you later. Students, Nick and staff, you guys stop doing Valentine's Day. It's Valentine's card. We would love to do that during activation tomorrow. We'll have some paper and things you can get from the workroom. It'd be nice to do something nice for our students. Have a great day.
Okay, so a radical, when we have friends down there, when it's a binomial, you have to multiply by the denominator. So if I have 5 plus square root 3, what's the conjugate?
5 minus 3.
Perfect, 5 minus square root of 3. But I have it on the top and the bottom because I'm really multiplying by a value of 1. And then other people are kind of lazy sometimes and don't put in this next step, and then they make a bunch of mistakes. This is a binomial. This is a binomial. Binomial. How do you multiply together binomials? Box method or distributive property, FOIL method. You actually have to use that. You can't just like multiply the each other. We need to like box method it or any of those things. Please take a moment, do your favorite method, and multiply these together. On top, I'm just distributing 1. Oh yeah, you guys remember fractions? We multiply straight across. That's fractions. You multiply straight across. On top. Method, you can use it totally. I guess I don't always use the box method because then I have to draw a box. Now I'm going to simplify what I got, and I have 5 minus square root of the bottom. I've got 25, and I'm going to take away 5, add 5 squared to 3. So what does that do? Let's cancel, and then I'm going to take away what is the square root of 3 squared. Yeah, those of you that said 3, I hope you were square root 9 and then found the 3 from there. Okay. Root, and we together. So you can go straight to the 3 if you want. Or you can think minus square root 9, which is minus 3. You can think in multiple steps as well. All right, a little bit of minus radical 3 over 2. There are 3 questions you have to ask yourself here. And we have done these 3 questions in chapter 3 when we were doing the quadratic formula, and we got answers that looked a lot like this, only they had plus minus instead of just minus. There are 3 things that you have to go through. One thing is that the denominator has to be positive. One thing is, here, I'm going to write them down. I'm going to write the second one to be simplified all the way. So square root of 3 does not break down. But if I had like square root of 40, right here, break it down. So the first thing is simplify the radical. This has to be positive. Thank you. They're my birthday nails.
It's your birthday?
Oh, we'll be together. But I don't get to see everybody because it's block day.
Happy
Oh, like
birthday.
not tomorrow. It's not tomorrow. A week.
Happy early birthday.
Thank you. It's next week, though. But you ladies know we can't just always get these done when you want to because they might. Okay. Oh, how old am I going to be? Like 32? Not anymore.
27.
29.
29.
I didn't mean
30.
29 was actually one of my not favorite years, but 30 was a good year. I met my husband when I was 30, so I gotta at least be turning 30 so I can at least have met my husband.
When I was 17.
Wait, why wouldn't you want to be that young again? Because she was over man.
I don't know, like in your 20s, unless you somehow like got a really amazing job, you're just like struggling to make ends meet, and just things aren't as, I mean, they're fun, but they're not as fun. And once I was 30, and then I met my husband, now I have babies.
And I got money.
He has money that I, no, I'm just joking. It's a different kind of fun, you know. No, I do enjoy going, I would enjoy going back to my 20s when I was skinny.
When you don't
Did he
Yeah,
say
she
don't
just
eat?
doesn't eat, dude. She just takes in the sunlight.
Okay, when I cheered for the Bengals, I was really skinny. No, you just had to be skinny. They don't care how you did it. Okay. It's not a good situation. We are on the third thing that is kind of the important one that people forget. So we're going to talk about that.
Wait, didn't Miss Fry cheer for the team?
Yes.
Did you cheer with her?
No, she's younger than me. I cheered when I think I cheered when I was like 26, 27. Like I was pretty old. Okay, no. What? I went.
Any money for cheering for the Bengals?
They make more money now. There was like a lawsuit and everything. But when I did it, it was $42 per game. I mean, it was $50 per game, but then with taxes, it was $42.
Wait, tax gonna go down? Yeah, any job you have tax. What is it now? Oh.
I don't know.
I thought you meant like.
I don't think it's much more now, but they get paid to practice now, and we didn't get paid to practice. So, all right, guys, we can have this conversation not on the camera. Right here, yeah. Sorry for anybody who really wanted to learn. You know Fifth Bell. You know them. All right. So what we have to do is we have to see if a number can be factored out of the numerator and cancel with a number that's factored out of the or factor out a GCF of numerator and cancel factor in denominator, which this one doesn't have one. So this is the final answer. Whew. Okay. All right, I have a second one right next to it. Right over here. I'm getting there. You guys getting there? Oh my gosh. Cancel with factor in denominator. When we have that example, I can show you, but I can't show you right now because I don't have that happen. All right, so here's our next one. We see a radical in the denominator, which means it's not simplified. And then we say, does he have friends? Did that bring friends? Yeah, the radical. In my den.
Yeah.
We need to exterminate this radical rat in the den. In the den, we have to put on a disguise a 1. We're currently not a 1. We're going to look like the what of the denominator? What's it called?
Conjugate.
The conjugate, which is 1 minus square root of 6. We're going to do that on top and bottom. And those are them in some parentheses before I start multiplying. On the, I'm going to distribute. I'm going to have square root of 2 minus, what happens when I multiply square root of 2 times square root of 6? We get square root of 2 times 6, which is square root of 12. That was stuff that we did yesterday. On the bottom, we are going to use our box method or our FOIL method. To multiply 2 binomials, I'm doing FOIL because I don't want to rewrite a box. And when you multiply square root of 6 times square root of 6, it becomes square root of 36, which is just 6. It should work like this every single time. My inside 2 terms cancel. Yes, question? Oh, yes. So square root of, 1 and then minus 6. I didn't do the 1 part yet. So on top, square root of 2 minus square root of 12. On the bottom, I get negative 5. Are all the square roots, are all the radicals here simplified? Square root of 2 simplified. So square root of 12, we got to break down square root of 12. That's like square root of 4 times square root of 3. We have the square root of 2 minus 2 square root 3 over negative 5. My second step says, this has to be positive. It's not. So we've done this before when we were doing quadratic formula. You're going to have to multiply by a value of 1 that makes it not negative. What makes this number not negative? Okay, so I'm going to multiply by -1 over -1 because it has to be a value of 1 that I multiply by. So we're going to distribute that -1 on top. We'll get negative radical 2 plus 2 radical 3 over positive 5. I did something that's not necessary, but it was bothering me to have this negative square root and have that positive there, so I just reordered. It's not necessary. I just felt like I needed to reorder it.
Wait, so what did we multiply by -1?
Why did we do the -1? Because you can't have a negative in the denominator. The only thing that's going to multiply and cancel that is another negative, but you have to do it on top and bottom. And then the third step says, can we factor out a greatest common factor from the top and cancel it with the bottom, which we can't. I wonder if the next one has a number to factor out. I'm working ahead real fast to see if it's worth our time to do. No, that one doesn't have one either. All right. So I'm going to move on to the next section. We've done 2 of our sections that we needed to do today. Oh, there's our answer key from before. The next thing that we skipped, I think, is the variables. Is the next thing we skipped this page?
Yeah.
Another big rule people tend to forget about, but we're going to go over it so you've seen it. Okay. If I asked you guys, hey, what's the square root of 25, you would tell me what? Okay. If I said, what's the square root of x squared? However, do we know if x is a positive? We don't know that. If I rewrite this one like square root of negative squared, if I rewrite square root of negative 5 squared, what answer would this be? It's actually going to be positive. And you'd square root it, and it would be 5, right? You can't just simply undo. But because of this whole situation, you'll see that if I had this here does not tell me that the answer would only be 5. This here tells me, so I'm comparing these two. Okay? This one tells me the answer is 5. I can see it even though I know my original number that I squared was negative 5. This one here, the answer is the original number, but it isn't always the original number that I squared. Always this rule that says we have to put in this absolute value to say that we are aware that this is a positive version of whatever my original number squared was. This is just for variables. Okay? So this rule only comes in when we have variables. If there's a number, you can find the answer. If there's a variable, you don't know what that number is, you just have to have an answer that would work once I knew that what. So now, they don't have a squared here, do they? What they've even see an example here is they wrote when n is even. So what I like to write, I don't write it this way. I write, if we have a situation where we have even, if we have an even root and an even power, when we find that of that x to whatever exponent you would get. So if you have even, now there's one more part to my little trick here. And this is an odd. I'll write it again over here. Maybe I don't have more space. I'll write it right here. An even root and you have an even power, and when you take it out, you have an odd exponent. That's when you need absolute value. So even, odd is my trick. Even, odd. This only happens with variables. If you have even, comes out odd, you will need absolute value around that. If it's anything else, you won't need absolute values. Okay, so we got a couple examples here. And at the same time, just going over how to do these. Did we do this one? I think my other class did this. So when I have numbers and variables in a square root, I'm going to separate those. My favorite thing, my easiest thing, what I think is the easiest to do is separate this to like cube root 64 and cube root y to the 6. Okay, now, is cube root 64 a thing? Like, what is it? It is 4. Now this gets a little bit more complicated. There's different ways we could do this. I'll show you how I do it. I like to change it into rational exponents. If you don't remember what rational exponents are, hint, there's an exponent. Rational means ratio or fractional exponents. Rational and fractional, they mean the same thing. Change this into y to the 6 over 3. Because remember, roots grow in the ground, so the root goes in the bottom. And then these will be applied together. Can I simplify anything when I do y to the 6 over 3? It's 2, isn't it? So we get 4 multiplied by y squared. There's no remainder when I divide 6 by 3, so this comes out perfectly. Like there's no radical left over. There's no cube root left over. There's no fraction. Abney. Yes, Katie. No, I'll show you what to do. Okay. So now the last thing we have to check is, since we have variables, we have to check the even, odd. Do I have even right here? No. Nope. Okay, done. No absolute value. Let's look at the next one. We've got the 4th root of x to the 4th over y to the 8th. So we've got the 4th root of x to the 4th, 4th root of y to the 8th. I'm going to look at these separately. There are different ways of doing this, but I'm going to look at them separately. So I'm going to rewrite this as x to the 4/4, and I'm going to look at this as y to the 8/4. So I changed them into rational exponents, and I'm going to simplify those. I get x to the 1st, y to the 2nd, and they go evenly. Those fractions go evenly, so there's no more roots left over. So now we check even, odd, where we have to look at each variable. So with the x's, even, odd, absolute value. The y's, even, odd. So yes, it's just for x. Has to be even, odd before you get an absolute value. So that one just gets the absolute value by itself. We're almost done. Let's look at A, because this one is not going to go evenly in. So what I would do first is I would separate, and I'd have like the 5th root of 4. I will write it as the 5th root of a to the 8th, or a to the 8th, not 8. I would write it as the fifth root of b to the 14th. And I would write the root of c to the 5th. Before I do any more work on this, I want to point something out to you. Is this even? So will I need absolute value? Good, I'm not even thinking about it the rest of this time because I checked right away like there's no way this is going to have absolute value. So now we're going to kind of do these individually and just put them back together at the end. So the fifth root of y to the 4th, if I were to take, I said that wrong, the fifth root of, what did I say y? The fifth root of 4 would be like the same as fifth root of 2 squared. If I were to take that and change it into 2 to the 2nd over 5, if I were to change that into fractional exponent, is that going to simplify at all? So guess what? I am just going to leave it as my original fifth root of 4. The next one I'm going to rewrite as a to the 8/5. Does 5 go into 8 at all? Yeah, so guess what we're going to do? We're going to use one of our properties, multiplying like bases. I'm just going to unmultiply them. I'm going to have a to the 5/5 multiplied by a to the 3/5. Why did I choose 5/5? Because I want to take out any counts. And then 3/5 would be the leftovers. So I separated the 5/5 out from whatever's left over. One more step, this is going to be an A. I'm going to put back into radical form. Okay, so you were too quiet, so I did not understand your question. Why didn't I multiply the exponents? Because when you multiply like bases, you add exponents. Right? That's why. Okay, I'm going to change colors because these are now looking like a lot of mess up here. So I'm going to do the b's. So b to the 14 over 5, that's going to separate into b to the 5/5. Do we have any more 5/5 in there? Because doesn't 5 go into 14 like 2 whole times? So I have another b. And then how many are left over? I've got 5/5. I've got 5 more fifths. How many are left over? 4/5. So both of these 5/5 become b's. So I've got b times b. And then I'm going to put this back into radical form. The fifth root of b to the 4th. And then I've got c to the 5/5 is what? C. So now at the end here, I'm going to put everything back together. The order would be anything that doesn't have a radical is going to come first. I'm going to put it in numerical order. There's no number without a radical. So I just have an a, I have a b squared, and I have a c without a radical. Then underneath, and they should all be fifth, I have an a 4th. So it's like doing 4 different problems, putting them all back together at the end. That's what we're doing. I will try to record a second video in my next class because they've actually already done some of this. They were ahead of you guys already. So I'm going to record a second video that has these last 2 examples on it because I know there's some questions and homework that are like these. You can watch that when you get stuck. You can also come see me in XH tomorrow if you get stuck on these or on any of it. I can. The assignment is in the book again. I'm on Canvas. Katie's looking at something real fast. I have it written on Canvas. Actually, Katie, I'm gonna I can go right back after I pull it up on Canvas. You got it. So we did not. I did have it on block day as well. So here's the assignment. It's on the pages you've already done. So if you use the book scan from yesterday, it should, all of those numbers should be on yesterday's book scan. Okay, so I didn't put up a new book scan. It should be the same. Like yesterday you did page 248 and you went to like number 70. Right. So the pictures of the book that I uploaded. You haven't done these yet. Remember, I was skipping around. Yeah.
Wait a minute, are these the same book numbers?
Yes. You just hadn't done those questions yet.